Hi everyone, and welcome to my class about reference frames. So today's class is going to be based on aircraft flight dynamics and control by Wayne Durham. And the reason why I picked this book is because it encompasses the most amount of reference frames and is therefore the most applicable and the most generic. So we're going to be covering the first part today, and that is the Earth-centered reference frame, the inertial frame, the local horizon frame, and the body fixed frame. The first question that you may ask today is, why do we need a reference frame in the first place? And that is because motion is relative. Depending on what you use as a reference, your velocity and acceleration will be different. So whenever there is motion, you have to precisely define what it is that you consider your reference. The reason why we use different reference frames in aerospace is because some vectors are more conveniently defined in some reference frames, while other vectors are more conveniently defined in different reference frames. Ultimately, when you're going to be deriving the equations of motion, all the vectors will have to be transformed from their original frame to a common frame so that the math can actually add up. The first frame today is going to be the Earth-centered reference frame, and it is defined as depicted here, with its origin at the center of a planet, with its z-axis as the rotation axis of a planet, with its x-axis, which forms a right angle with a z-axis, and the y-axis, which forms a right angle with the xz plane. So there are two main derivatives, and that is the ECI, Earth-centered inertial, and the ECEF, Earth-centered Earth-fixed frame, and the main difference between the two is that the ECI is inertial, so it does not rotate with a planet, while the ECEF does rotate with a planet. Both their x-axes are tied to fixed directions, and that is the vernal equinox for the ECI frame, and the 0 degrees latitude, 0 degrees longitude for the ECEF. The ECI frame is useful to describe the motion of celestial bodies and spacecrafts, while the ECEF frame is useful to describe the motion of objects on the Earth's surface. So we have a little animation here to demonstrate the difference between the two, and you can see that the ECEF frame is rotating with a planet, while the ECI is tied to a fixed direction, which would be the vernal equinox. So the next frame is going to be the inertial frame, and it is probably going to be the most important one because everything in flight mechanics is relative to the inertial frame. It is fixed to the ground, its x-axis points north, its y-axis points east, and the z-axis points down to the center of the planet. It is the only frame in which F is equal to ma stands without any adjustments or additional terms, and in order to make it inertial, a number of assumptions need to be made, and that is that the Earth is flat, non-rotating, and non-accelerated. So the book mentions a very generic version of the inertial frame, and that is a frame whose origin can be any point that is completely unaccelerated. But for the purpose of this class, we're going to consider that it is fixed to the ground on planet Earth. The next frame is going to be the local horizon frame, and it is essentially an inertial frame attached to the center of gravity of the aircraft. It will translate with the aircraft, but it won't rotate with it. Its axis will point in the exact same direction as the inertial frame axis, and that is north for the x-axis, east for the y-axis, and down to the center of the planet for the z-axis. The last frame is going to be the body fixed frame, and this one will translate and rotate with the aircraft. Its x-axis will come out of a nose, its y-axis forms a right angle with the x-axis and comes out of a right wing, and the z-axis forms a right angle with the xy plane. It is angled with respect to the local horizon and ground frames by the Euler angles, with respect to the stability frame by the angle of attack alpha, and with respect to the wind frame by the angle of attack alpha and the side slip angle beta. Alright, this is it for today. Thank you very much. See you next time.